Good evening. Yes. So in the last class, we have done the presentation related to our mini projects. Okay. So in today's class, we will go to the next topics. That is motors. Okay? We will interface servo motors and DC motors using the Arduino Uno controller. Okay. So the servo motor is used to angular movement. Okay. So where for example your like door. Okay. So in rooms and all there will be a doors. So which will rotate from 0 degree to 90 degree, 180 degree like that movement. We use servo motors and the DC motors for the continuous motion. Okay, continuous rotation means robotic wheels. Okay, so when you are building the robots and all for the wheels purpose we use DC motors and for the arms. Okay, so in the industry and all there will be robotic arms, so for those purpose we use servo motors. So first I will explain about the servo motors. Okay. So almost everyone know about the motor working. Okay, so basically the motor will convert electrical energy into mechanical energy, or else kinetic energy, or else rotational movement. So that is the main thing of the motor. Okay, so I will present this PPT now. Okay, so this is a servo motors we are using now in the Tinkercad. Okay, so this servo motor is only used for the angular movement, so which is from 0 degree to 180 degree. You can set it to any angle. Okay, so you can set it to 40 degree, 65 degree. Okay, so the angle here you are seeing is controls the whatever component used. Okay, so when you are making a smart home means you can use this angle for the doors and all. So when you are making a robotic arm means just you can place the axle, okay, arm of the robot to this angle. So by this we can rotate the servo motors to different angles. Okay, it will not rotate less than 0 degree and it will not rotate more than 180 degree. Okay, 0 to 180 degree you can put any angles. Okay, so it has total 3 pins. Okay, so one will be a signal pin. Okay, signals should be uh, PWM signals. Okay, PWM is nothing but like pulse width modulation. So always when you are using the servo motors, always you need to use the PWM pins. Okay, so these PWM pins will generate duty cycles based on the frequency which matches the servo motor. Okay, so for that we use the PWM signals. Without PWM signals it will not rotate. Okay, always you need to give the PWM signals to the servo motors. So after this it contains multiple components in it. Okay, so here just you are seeing one block and the cable 3-pin cable from that block. Okay, inside that blue color block there will be multiple components. Okay, as you can see in this slide, so there will be one DC motor. Okay, and DC motor will convert electrical energy into rotational movement. Okay, now so here there will be no angular movement, there will be a continuous rotation. And when it comes to the gearbox, so this is a gearbox. Okay, so all the gears will be connected here. So this gear will convert continuous rotation into angular movement. Okay, so for that purpose we use the this gearbox. Okay, it will not rotate the angle continuously, it will only rotate the angle from 0 degree to 180 degree. Okay, So after this, parallelly there is a one potentiometer connected to the gearbox. Okay, so this is the gearbox. So here one shaft is connected with the potentiometer, which is the resistor. Okay, potentiometer is nothing but a resistor, so which will act as a feedback system. Okay, how it will give the feedback means, so let us consider the servo is at 90 degree. Okay, 90 degree, when you suddenly the power you remove the power supply means, so when after the if you after you again give the power supply means, it should rotate from the 0 degree, not from the 90 degree. Okay, so when you remove the power supply and again you connect the power supply means, it will send the feedback. So where the angle is placed, that angle will be feedback to the control system. So where you can see in the bottom side there is a control unit, that is a control circuit, which will take the feedback from the servo arm. Okay, so this is servo arm, so it will take the feedback of an angle and it will correct the angle to the 0 degree. Okay, whenever you power off and again power on means, it will come back to the 0 degree and it will start from the 0 degree, like that. Okay, for that purpose we have used a potentiometer with the gearbox. Okay, it works as a feedback system. So all this will be placed inside a single unit, so that is called a servo motor. Okay, so when it comes to the stepper motor and all, that construction will be different compared to servo motor. This is only for the angular movement. Okay, so here there will be a small DC motor which you can power supply from the controller itself. Okay, when it comes to the big DC motors and all, you need external component called a motor driver. Okay, which is used to control the direction and speed of the DC motor, because so there will be huge back current, back EMF generated when uh, you run the motors. In motors and all, there will be mechanical movement. There will be a back EMF generated from that motor and it will affect the controller. To avoid this, we use one motor driver for the larger capacity motors. So there is next motor we will use motor driver, that is called L293D IC. So we will use that, we will control that DC motor. Okay, I will show that later, but now so see this servo motors. Okay, so that one will be like a yellow color wire, so from the servo motors. So here there will be three color combinations, one is yellow, one is red, one is brown color. Okay, so yellow color indicates the signal pin, so where you can connect the signal pins. In Arduino there will be a 6 PWM pins. The pin numbers are 3, 5, 6, 9, 10, 11. 3, 5, 6, 9, 10, 11. These are the 6 PWM pins, so you can connect anyone to the servo motors. Okay, other than this, if you connect other than these pins means, it will not work. Okay, these are the default PWM pins you should connect the servo motors. Okay, so this is all about the construction and the wiring connection of the servo motors. So basically this model, that is SG90, so this servo motor will rotate only 0 to 180 degree. Okay, when you go to another model and all, there will be 360 degree. Okay, we can control the angle up 0 degree to 360 degree. Okay, but here in the servo motor, that is the SG90 model, we will only control 0 to 180 degree, that's all. Okay, and in the next slide you can see the robotic arm is picking one ball and placing it in another location. Okay, so for this movement we use the servo motors. So see, as you can see in this arm, here we have placed one servo motor for the movement of forward and backward. Okay, so after that, for this joint there will be another servo motor where it will up down for the up down movements. Okay, then another the servo motor here, so which will move the gripper. Okay, so which will move up and down for the gripper side. And next another servo motor is here, which will hold the particles, ball, metal objects. So to hold that one, we use another one servo motors. Okay, total there will be 4 to 5 servo motors in a single arm, robotic arm. Okay, and here you can set the angle for 0 degree, 60 degree, 90 degree. Okay, whatever the angle you can set it as to the servo motors. Okay, so this is all about the like construction and working of the servo motors. So next we will like do make the connections and check the output in the Tinkercad. So all of you be ready with the with your laptops and open the Tinkercad website. Okay. Okay, so this is a Tinkercad website. So here we need to click on the create. This is a dashboard. Okay, click on the create, click on the circuits. Okay, so now we have a empty page. So here we need to take one Arduino and one servo motor. So Arduino you can get it from here, Arduino Uno R3. So just you can place it here. Okay, so now we have taken the Arduino board, and next we need a servo motors. So scroll. Yes, so here you can find micro servo. This is a servo motor we are going to use now. Okay, just take it and place it here. Okay, so this is a servo motor. This is a top view. Okay, so this will be a top view. So here you can see the angle and the gearbox below that. Okay, so after the below that there will be a DC motor and the control unit. Okay, so here you need to connect these 3 pins. So here you can find the pins. One is signal pin, that is orange color or yellow color, and one is power supply, that is connected to 5 volts, which is red color, and another one is ground pin, which is a brown color. Okay, so that is the ground pin. So just you can place the mouse cursor here and you can see the pins. Okay, so these are the 3 pins for the servo motors, and you can rotate this servo motors by clicking here. Okay, now it is vertical, so you can make it to horizontal like this. Okay, so we will connect the servo motor to the Arduino. As I told you, in the Arduino Uno board there will be a 6 PWM pins, that is 3, 5, 6, 9, 10, 11. So these pins are usually used to control the LED brightness and motor speed. Okay, so for this purpose we use these PWM pins. Okay, now so PWM pins are nothing but it will control the input like input power supply for the motors and all signals, motors and all. Okay, when it comes to the LED and all, they will change the duty cycles. Okay, they will limit the current. Okay, and they will control the brightness. So like that, here we are using the servo motors for the angular movement. So we should connect it to the PWM pins. Okay, so first I will take the signal pins and I will connect it to the pin number. So any pin number, you can connect it to any pin number. I will connect it to pin number 3. Okay, since it is like all the PWM pins will have the signs like sine waves. Okay, so this is having the sign. Okay, what are all the pins having the sign? This sign means these are the PWM pins. Okay, remaining are not PWM pins. Those are like normal digital pins. Okay, should not use when you are connecting the servo motors. You should only use the PWM pins. Okay, so after this I will connect the 5 volts pin, power. So connect it to the 5 volts here. Okay, so after this connect the ground pin. So ground, connect it to the ground pin here. So now we have connected positive pin and the ground pin. Okay, so these are the 3 pins we need to connect when you are interfacing the servo motors to the Arduino. So now the connection is finished. Let us go to the programming part. So here we need to use one library file called servo.h. So I will explain about that. So you can connect up to 6 servo motors. Okay, so there are total 6 PWM pins. You can connect 6 servo motors to the Arduino boards, and you can control all 6 servo motors. Okay, so you can also control the servo motors using IR sensors, PIR sensor, ultrasonic sensor, or any sensor. So you can take the sensor output and you can write the condition and you can control the servo motors. Okay. Yes. So let us go to the programming part. Yes. So first, like we should include one library file called hash include servo.h. So S should be capital. Okay. So after this we need to take one variable name called my servo. Okay, my servo is nothing but like variable. If you are using multiple servo motors, means you should take servo 1, servo 2, okay, like that. So like this you need to type the program. So after this there comes the void setup. Okay, na. So after void setup, so you need to mention the pins. My servo dot attach pin number. We have connected the pin number 3. Okay, so here we have connected the signal wire to the pin number 3. That's why we in the program you should mention pin number 3. Okay, so after this you can close the setup and open the void loop. First try the servo motor like giving direct instructions. Okay, after that we will control speed or for extra activity and all. Okay, so first just turn the angles. So initially it will be 0 degree. So now I need to rotate the servo motor to the 90 degrees. Servo dot right. Okay, servo dot right 90. So it will rotate at the 90 degree. So after that give some delay 2000. So after 2 seconds it will move to the next angle. Okay, so again after this my servo dot right 0 degree semicolon, again delay 2000. I will show the same in the Tinkercad. Okay, so here you need to change the blocks into text. Click on the continue. So after this I will paste the code here. So click on the start simulation. So there is an error. Okay, so it tells like my servo dot servo here. Okay, so here there is a small change here. So what it will means, so first you need to write the servo and after that you should write my servo. Okay, servo space my servo semicolon. Okay, so this is the correction. So let us run the simulation. Okay, so now we have done with the programming part. Okay, so it is rotating now. For initially it will be 0 degree. So I will stop simulation. So it is 0 degree now. Okay, So first we have rotated the servo motor to the 90-degree angle. So I will start the simulation. So it will like rotate exactly to the 90-degree. Okay, 90-degree means vertical, horizontal is nothing but a 0-degree. Okay, so now we can increase this 90-degree to 180-degree here. So after 90 it should rotate to 180-degree. So just change, I will change the angle, so 90 to 180. So 180 is the maximum. If you give like a 200, 250 and angle means it will not rotate, it will stop at 180-degree, that's all. Okay, so now I will start the simulation. Yes, so this is a 90-degree, this is the 180-degree, again it will come back to the 0-degree. Okay, so like this you can control the servo motor using the PWM signals. Okay, so but here you cannot control any speed of the servo motors. So when you when you need to control the speed of a servo motor means you should use the for loop. Okay, so I will show that one also, how to control the speed of the servo motors. Okay, so angle is just like this. So now you can use the IR sensor, or else you can use the PIR sensor, like the top sensors, and you can directly control the angles. Okay, for example, take an example of a mini project, so where the automatic door, okay, automatic door. So if any movement is detected, open the door. Okay, if any person comes near to the door means the door should be automatically opened. Like that project you can do using servo motors and PIR sensor. Okay, I will show that later. So before that I will show how to control the speed of the servo motor. Okay, so I will show the programming part here. There is no hardware connection changes, there is only software, that is programming changes to control the speed. So how you should control the speed means, first you need to write the for loop for, okay, int angle. So first there will be angle will be 0-degree, 0. Okay, so after that the angle less than 180. Okay, so after that angle increment. So this is a for loop for to increase the angle from 0-degree to 180-degree with the increment. Okay, plus means it will increment one angle every time. Okay, 0 to 180 it will increment one angle every time. So after this just you can write the like my servo dot write angle. So here we need to mention the variable name, so because here we have already taken the values and stored it in the variable, so that's why we are just writing the servo motor with this angle. So after this angle you can add that some delay. So here the delay must be very small, that is like 15. Okay, I will give 15. So when you need to reduce the speed means just you can increase this delay. Okay, when you need high speed means you can increase when you need high speed means you can reduce this delay. When the speed is when you need to reduce the speed means you can just increase this delay, that's all. Okay, so now I will close the for loop, and again another one for loop for the decrement. Okay, so here we have increased the angle from 0-degree to 180-degree. Now we need to we need to rotate the servo motor from 180 to 0-degree. For that again you should write the for loop for int angle is equal to 180. So here the maximum value will be 180. Okay, so here it will start from 0, that's why we have written 0. Here it will start from 180, so that's why we have written 180. Angle, so here angle should be greater than 0. Okay, angle should be greater than 0. So after that angle will become decrement, because here we are reducing the angle from 180 to 0-degree, that's why we are negative. You should type 2 times. Okay, so after this again my servo dot write angle bracket close semicolon, so delay 15. So I will show how to control the speed and all. So after this, that's all. So now we have rotated the servo motor from 0 degree to 180 degree and also 180 degree to 0 degree. Okay. So like between these two operations, just you can add one delay called delay 1000. So to avoid sudden changes in the angle, so you can add the delay after the increment and after the decrement. Okay, delay 1000. So here we have used two delays. It will stop for 1 second after the increment. It will then after the decrement it will stop for 1 second. Okay. So now let us run the same program. So here you can see the servo motor is rotating from 0 degree to 180 degree. Okay, 0 degree and 180 degree. Again it is rotating from 180 degree to 0 degree. Okay, now like this you can control the speed. So now it is like speed is reduced. So you can increase this delay and you can reduce further the speed of the servo motor. Okay, so if I will make the 15 as 20 or 25, I will make it as 25. You will see the difference. So I will click on the start simulation. So now you can see the servo motor is rotating very slowly. Okay, so here, so compared to the like old one, this is very slow. Okay, so you need a still more reduce the speed means just you can increase this to the 35. Okay, I am increasing the delay means the speed is reducing. Okay, so now you can see the speed is reducing. Okay, now so if I make the same delay as like 5, so I will give this delay as a 5, so then you can see the speed will be high. Okay, so now the speed is very high compared to the old interfaces.
ಇದೈತಲ್ಲ.
Okay, so you can connect up to 6 servo motors. Okay, so just you need to change some connection and also in the programming part. Okay, na? So now I will show one example where you will connect one PIR sensor and you will control the servo motors. Okay, na? So I will take this PIR sensor. So PIR is like nothing but like it will detect the movement. So I will connect that sensor here. Okay, so I will place the sensor here. Ground will be connected to the ground pin here. Okay, and then we need to connect the positive. So this is the power pin, so I will connect it to the 5 volts pin. Okay, so next we need to connect the signal pin. So signal I will use one digital pin, that is you can use any pin, so I will connect it to the pin number 8. Okay, so now we have connected one sensor, one servo motor. Okay, so let us read the input from the sensor and you can control the servo motor. So just I will add the sensor part in the programming program. So first you need to set the pin as input when you are using the servo when you are using the sensors and all. First thing you need to do is mention the pin as an input. So pin number 8 will become input. So close the bracket, semicolon. So pin number 8 will become input. So after this just take an variable that is called status is equal to digital read pin number 8 semicolon. Okay, So after this, just we can add the condition like if status is equal to 0. Okay. Okay, so then it should increment from 0 degree to 90 degree. Okay, so open the door like that. Okay, 0 to 90 degree means door will open. So after this again you should close after the first for loop you should close one bracket which is if condition bracket. Okay, so you should close two brackets here. One is for loop, one is for if condition. And after this you can remove this delay and write else part. Else, open the bracket again. In the else part you should write the decrement part. So after else again you should close one bracket. So this bracket is one is for else, one is for loop. Okay, so this is all about the like including the sensor part in the servo motor. Okay, so after this just I will run the simulation. Okay na. So now like I am not connected any or not detected any movement here. Okay, so if I move if I move this like sensor, it will sensor is detected means servo motor will rotate at the like 180 degree. Okay, so I'll show you one more time. Wait a minute. So for this program you can also add the serial monitor. So I will show the status in the serial monitor. Serial dot begin 9600 semicolon. So first in the first state, so after reading the sensor, okay, so just print the serial dot print. So object double with the double inverted comma, close the bracket, semicolon. So after that serial print, serial dot print ln. So you should print the variable here. Okay, okay, let us run this program. So now the object is 0 degree 0, so there is no object movement detected. So I will move the near the sensor. Now it becomes 1. Okay, so now the object is 1. So object or movement, so you can display anything. Okay, so I will change this object to the movement. Okay now. Yes, so here we need to change the angle to 90 degree. 0 to 90 increment, 90 to 0 decrement. Okay, so now the movement is detected, so it is rotating at 90 degree. Okay, so to avoid this miscommunication, just you can remove the for loop here. Just remove this for loop, just you can mention the angle directly. Okay, so now I will remove this for loop and mention the angle to the 90 degree, and here 0 degree. So now the servo will not rotate like easily, it will stop at a correct angle. So for loop we will only use it for the speed control. Okay, so now you can see the angle is 90 degree when there is a 0, when the movement is not detected, the angle will be 90 degree. When the movement is detected, the servo angle will become 0 degree. Okay, like this. So or else you can interchange this one, so you can make it 90 as a 0 and 0 as a 90. So now you can see when I click on the start, the servo motor will be like still. Okay, it will not rotate at any angle, so it will be 0 degree angle. When the movement is detected, it will rotate at 90 degree. Okay, so by this you can like change the program, edit the program using the sensor based on the sensor signals. Okay, so and in the serial monitor also you can display like yes, so here I have mentioned only movement. Okay, movement 0. So here you can also mention the servo door open, door close, like that. So I will show that one. Okay, so inside if condition I will display, so you should write print ln. Okay, because so it will print in the next line. So here I will write door closed. Okay, so here I will display door open. Okay, like this. So I'll click on the start simulation. So now in the servo motor, in the serial monitor it is showing the sensor output is 0 and door status is closed. Okay, so now I will detect one movement. Okay, so now you can see the servo is 90 degree, and in the serial monitor the sensor output is 1, and also door is open. Okay, now like this you can do using any sensors and all. Okay, you can control the motors using any sensors. So for the same servo motor you can use the ultrasonic sensor, and you can make the project like smart dustbin. Okay, when anyone detects the detects the ultrasonic sensor, open the servo motor, like open the dustbin cover, and you can put the waste inside. Okay, so like this these examples can be implemented for the variety of projects. So and you can connect multiple servo motors, and you can control at the same time. Okay, so in the place of this PIR sensor, I will connect one push button. Okay, I will show how to connect the push button and control the movement based on the switch press. Okay, now so now I will use like 2 to 3 push button. Okay, now so one for 90 degree. Okay, one for like 60, one for 60 degree, one for 90 degree. Okay, then another one for 120 degree, and one more for 180 degree. Okay, and also you can add one more for the 0 degree angle. So okay, I will add one more switch for the 0 degree angle. Okay, so like this you can control the movement of the servo motors. Okay, so now we have used like 5 switches. First one like 180 degree, or like 60 degree. Okay, consider it as a 60 degree. Then now 120 degree, 180 degree. Okay, 0 degree. Okay, so I will remove one switch, so I will connect only 4. That's all. So, okay, so 0, 60, 120, 90. Okay, so now we need to connect the grounds. So I will take the ground, connect the ground pin to the breadboard. Okay, connect all the push button grounds to the breadboard here. okay, like this. So after this, like you can take the another color, or I will take the orange color. So then you can connect the switch to the pin numbers. Okay, so for the first switch I will connect it to the pin number 4. Okay, or else you can connect it any pin numbers. I will connect it for pin number 6. Then I will take another switch. Okay, I will connect it to the pin number 7. Okay, now, and like this you can make the connections neatly. Okay, and don't use these pins. Okay, so this is will be internally shorted, so you need to use this pin or this pin. Don't use this one and this one. Okay, because 2a and 2b are internally shorted. Okay, 1b and 1e are internally shorted. You have like you need to connect between 1b and 2b. Okay, so like this is the correct one. So then connect this pin to the next digital pin. So I will connect it to the pin number 8. Next one, so connect this pin to the pin number 9 here. Yes, so we have done with the all the connections. Now we need to change the programming part. Okay, click on the code. Okay, so sensor and the switch similar code, so both are similar code, just we need to increase the numbers. So here we have used 4 switches. So and when you are always when you are using push button means you need to write pull up, input pull up. Okay, so if you have not written this line means it will not work. So always when you are using the push button means always you should use input pull up. Okay, so pin number 6, starting from the pin number 6, 7, 8 and 9. So these are the switch pins. Okay, so now we need to read the status 1. So first I will remove all the programming part in the void loop, so don't get confused. So in the status 1 we will read the pin number 6 and save it to the status 1. Then we will read the switch 2 and save it in the status 2, and pin number will become 7. Okay, so after this, status 3, pin number becomes 8. In status 4, then digital read 9, 6 7 8 9, 6 7 8 9. Okay, so we have read all the status of the pins and we have saved in the different variables. Okay, so after this you need to write the condition. If status 1 is equal to 0, okay, then the servo need to rotate 60 degree. Okay, for that my servo dot write 60 degree. Okay, semicolon, close the if bracket. Again you need to write another one condition for the status 2. Then the angle should be 120 degree. For the status 3, the angle should be 180 degree. For the status 4, the angle should be 0 degree. Okay, like this. Okay, na? And also if there is a last moment, for the last moment, so you can put the else. Okay, so else so in the else part just mention the servo motor to the 0 degree. Okay, either you can give it to the condition, or else you can just So at the last you can write the else and you can place the servo motor to the 0 degree angle. Okay, done. So next I will click on the start simulation. So let us see if any error exists or it will execute. Okay, so now it is executed. So just you can check the buttons now. So I will press the first button, so it will rotate at the what angle. So we have given 60 degree angle. Okay now, so which is for the pin number 6, status 1. If the status 1 is equal to 0, then rotate the servo motor to 60 degree. Yes. So here you need to use the if else condition. Okay, if first we have written if, then if else. Okay, wait a minute. Okay, so here you need to just remove the else part. So this was extra, so just so okay, so remove the else condition. So here we have written for the condition status 1, status 2, status 3 and status 4. Okay, so now let us click on the start simulation. Okay, so when you click on the first switch, so it will rotate at the 0 degree, 60 degree. Okay, so when you press on the second switch, it will rotate at the 120 degree. Then if you press the switch at third switch, it will rotate at 180 degree. Okay, again if you press the fourth switch, means it will rotate back to the 0 degree. Okay, like this it will work. Okay, so now it is 0 degree. Okay, so when you press first switch, 60 degree, 120 degree, 180 degree and 0 degree. Okay, so this is about multiple examples based on the servo motors. So and there are another few examples you can try with the servo motors. Okay, check those examples. I will give the assignment questions based on the servo motors. Okay, so you can do smart arm control. Okay, and door control. Okay, and you can use the soil moisture, rain sensor and all. So you can rotate the servo motor based on this. You can use the LDR, soil moisture sensor. Okay, and you can also control the servo motors using the temperature sensor. Okay, so in the sensor part you can see multiple sensors and all. And one more thing, you can rotate the servo motor based on the flux sensor input. Okay, so when it comes to this flux sensor, if you fold this sensor means it will give the different values. Okay, so just I will show this one. So if you like bend this sensor, okay, now consider if you bend this sensor like this, the servo motor should rotate according to this. If you write in the add in the program means it will rotate as per the sensor input. Okay, so just you can like increase this and reduce this. The servo motor will rotate based on this sensor input. So this also can be done using the servo motor and flux sensor. Okay, and there are multiple sensors. You can use any one type of servo sensor and you can control the servo motors. So and there are multiple inbuilt examples also in here. You can use those one and you can run the programs. Okay, so next one is a DC motor. We will continue it tomorrow. Okay, so now these are like multiple examples based on the servo motor I have shown you. You can also display the servo status in the LCD display also. That is also one example. So avoid making interface only one device. Okay, connect multiple device and when I explaining you can do a mini project also. Okay, so this is about today's class. So if you